Hello, good morning, good afternoon, everybody. Welcome to the Kraton SPC Inventor Series webinar. My name is Christopher Schuren. I'm the market manager at Kraton, and I will be facilitating the webinar today. In this webinar, we will focus on enhancing circular design for the automotive industry. We will start with a short introduction to Kraton, followed by discussing some of the key trends in the automotive industry. Following to that, we will cover some of the key points, all targeted towards a more sustainable design with some specific examples of value in use. We plan to use the last 20 minutes of this event for a Q&A session, so therefore please submit your questions via the questions tab in the bottom right of your screen. The webinar is being recorded and you will receive a link to the recording after the event. I'm excited to introduce our key speakers of today, Brian Stefanik and Raja Dharmarajan. Brian is a seasoned professional with over 20 years of experience in the plastics industry across different roles in strategic marketing, new product innovation, and sales. At Kraton, Brian leads market development for the automotive segment. On the other hand, we have Raja. Raja brings over 35 years of extensive experience in the polymer industry, specializing in product, process, and application development. His expertise is facilitating innovative solutions for Kraton's customers by leveraging his broad knowledge in polymer modification and compounding application. Kraton is the inventor, in fact, of styrenic block copolymers and a global leading producer of specialty chemicals. Headquartered in Houston, Texas, we have 30 manufacturing sites and 8 innovation centers to support our customers globally. This year marks the 4th consecutive year of Kraton receiving the EcoVadis Platinum Sustainability Rating, which is a true statement of sustainability being central to everything we do at Kraton. We are also an active member of Together for Sustainability, as well as regional plastic recycling associations. This year, we also received the ICC Plus certification for our plant in Belpre, Ohio, in addition to the already certified plant in Berre, France. Kraton focuses on market-driven innovation to help our customers address the key industry challenges across a broad range of end-use markets. Our polymer solutions can be found in multiple applications such as protective films, personal care, automotive, medical, and many more. Our broad portfolio of solutions, combined with a strong commitment to innovation, supports our customers' solution development across a wide range of end-use markets. The industry focus on sustainability continues to grow, driven by changing regulations, increasing corporate commitments, and shifting consumer preferences. Need for sustainable design as a megatrend goes hand in hand with increasing expectations to further enhance the performance and durability of end products, while optimizing the use of resourcing, improving operational efficiency, and reducing the energy consumption. At Kraton, we believe that technology innovation plays a critical role in supporting the industry journey towards a circular economy. That is why we are excited today to share our innovations to support your solution development. With that, and without further ado, I will hand over to my colleague Brian to share our approach on sustainability for the automotive industry.
Well, thanks, Christophe, and thank all of you for joining us today. I'll now shift the focus to the latest automotive industry trends and share some insight into areas that can help you design for circularity. So as a quick background, Kraton polymer solutions are used in a wide variety of automotive applications. So as you can see from here, our solutions are used in interior, exterior, and underhood applications, such as bumpers, glass run channels, roof seals, soft touch interior applications, just to name a few. But some of our new applications can also help improve impact resistance of EV battery housings and help replace EPDM in underhood applications and weather seals. But for today's conversation, we'll really focus on 4 main areas, and those are translucent TPO bumper fascia, minimizing use of recycled content, incorporating natural fibers, and end-of-life recyclability of vehicles. So we'll touch on how Kraton sustainable solutions can enable circular design and help the automotive industry do things like lower carbon footprint, integrate recycled and renewable content, intentionally designed for end-of-life recyclability, and of course, lightweighting vehicles. So what are the key trends affecting the automotive industry today? So with the strive towards electrification, EVs are offering new opportunity for design freedom. So a lot of the paradigms are being broken, often led by the new OEM entrants. So some of the smaller players out there who really use design as a way to streamline parts and reduce complexity. So it's really challenging the way things are done in the past. So as an example is elimination of a front grille no longer needed on electric vehicles. So opens up the opportunities to new designs like translucent TPO bumper fascia, where lighting and signaling can all be incorporated into a streamlining the production process. Secondly, reduced carbon footprint is really the next big prerogative for the automotive industry. So we're seeing an increase in the amount of sustainable materials. So think recycled or bio-based. Also the need for simplifying production processes and even more scrutiny to find sustainable suppliers, because the whole product life cycle is really being considered in the OEM's LCAs or life cycle assessments. And lastly, the end-of-life recyclability. Really, there's a growing demand to recycle vehicles end of life, but then also reuse those materials when producing new vehicles. So this means using monomaterials that are easily recyclable and also enabling recycled streams that can meet OEM performance specs. So traditionally, the performance of recycled plastics has presented challenges limiting their usage in the automotive industry, but right now there are options to improve their performance. So here's a snapshot showing how many of the major OEMs have committed to achieving carbon neutrality from 2038 to 2050, but it's quickly approaching. A big part of that strategy will be using recycled plastics in new vehicles. In addition, legislation is also driving this, with the EU Commission proposing end-of-life vehicle directive. So this is really intended to drive circularity, with new vehicles requiring that 25% of plastics come from recycled streams, and end-of-life, 30% of all plastics will need to be recovered and recycled. So although this is starting in Europe, we expect that all major regions will adopt similar goals in the future. So before we dive into our solutions, we just wanted to pause and hear your number one goal for your innovation project. So you should see on your screen, you should see some options. If you don't mind selecting which one you think is most important for your innovation projects, and we'll share the answers here shortly. So it looks like we have a few responses that tie really for the top two are increasing sustainable content. So really talking about the bio-based renewable materials, and then also improving performance of the recycled streams of plastics out there. So we'll definitely be covering those as we move forward with the webinar, but thanks for sharing those. And we'll now shift gears talking about some of Kraton's solutions related to circular design. So as I mentioned earlier, EV design freedom has made way for the translucent TPO bumper fascia. And this may be new to some of the audience, but this is really the idea that we have parts made exclusively of polyolefin-based TPO, and they're also translucent to allow backlighting illumination. And so the monomaterial design makes for a really large part that is fully recyclable at end of life. But replacing traditional polyolefin TPO bumpers with this translucent material has its challenges. So as you can see, depending on the OEMs and depending on the region they're in, the exact performance spec can really differ. And so what we do know is that the OEMs want high stiffness, high impact, and good processing with low CLTE. But there's also a new variable that we now need to optimize, and those are really the optical properties. So we need enough haze to give the bumper a uniform look, but we also want enough transparency to allow the backlighting to display when the LEDs are illuminated. So typically, or traditionally, talc's been used to achieve high stiffness, but in the translucent part, it actually hurts the optical properties, and then removing it also hurts our CLT performance. So Kraton impact modifiers can be used to help the improving toughness. We also see an added benefit of improved optics. So the reality is that many of the OEMs target very specific performance specifications, and that really one size may not fit all. And so that's really where we can help. And so I'll now hand over to Raja to walk you through some of the details of our TPO solution.
Thank you, Brian, and thank you for joining us today. Most of you are familiar with conventional TPOs, where we are trying to optimize flow, impact, and stiffness. As Brian alluded to, for designing for semi-transparent or translucent application, optical properties also become very important. So right now we have an optimization that requires 4 factors, which includes the optical properties as well. So when we started thinking about how we design solutions for this application, we first focused on what type of a polypropylene matrix do we begin with. So the best matrix to use would be a PP homopolymer, because a PP random copolymer or an impact copolymer has lower optical properties. It does not have the transparency. Okay, with that being said, we also have to meet other requirements such as high stiffness and high impact strength. So the and high flow as well. So the homopolymer that we selected has a stiffness of 2,000 megapascals, and has a 20 and a flow of 20 MFR, which is in the right range for injection molding application. So before we did our detailed modifier study, we did some benchmarking study to figure out what is the level of modifier that we need in order to achieve high impact strength, both at room temperature and low temperature. So this was a perturbation study where we varied the modifier from 20 to 30%. And we found that we need at least over 20% modifier content to achieve a no-break notched ISOT. So in this study, we are showing a series of unfilled TPO formulations in which the polypropylene matrix is the homopolymer 20 MFR with a 25% impact modifier. So we are comparing the performance of our both commercial Kraton polymers G1657, G1730, and 2 new grades, SEBS1 and SEBS2, with a polyolefin elastomer, which is Engage 8200, a product from Dow Chemical. So we are plotting the performance relative to the performance of the POE. So the horizontal line that you see there at the 100% is the performance of POE, and we are comparing how each of these modifiers compare with that of POE. So we measure transmittance and haze using 3 millimeter injection molded samples. And as you can see here with our new SEBS1 and SEBS2, we have fairly high transmittance and also low haze, which is what Brian alluded to. The best combination, having high transmittance and a certain minimum level of haze, but lower would be better. Our G1730 commercial product also gives us the same combination. So how does it look like if you have an actual injection molded part? So in order to do that, if you look at the illustration on the left, we injection molded a 2 millimeter thick plaque. One is a TPO compound containing the Engage 8200, and the second is the TPO compound containing our G1730 grade. So we have the Kraton logo at the back, and we did shine an LED light also to see how well the logo shows up. And you can see very clearly that with the SEBS solution, the logo is the letters are very clear and distinct, whereas with the POE solution, they are quite hazy. So to understand how these why and how these modifiers work, we actually did some microscopy study, and in this slide, I show you atomic force micrograph or AFM images of the TPO compound. The slide, the micrograph on the left-hand side uses our commercial G1657, which is one of our workhorse TPO grade for classical TPO applications. And on the right, we compare that with SEBS1, which is our experimental SEBS grade that we have developed for the semi-transparent application. So the dark phase is the polypropylene matrix. The light phase is the modifier. So we took multiple sections, and with that, we were able to do an image particle size analysis of the dispersed phase, which is the modified phase. These pictures are 5 micron across, as you can see here. So when we did the particle size analysis, we found out that with the G1657, we get an average particle size of about 230 nanometers. Whereas when we use our new ACBS1 modifier, we get an average particle size of 60 nanometers. That is almost a 4-fold reduction in particle size. So it is not a surprise that because of the smaller dispersed particle sizes of the modifier, we get better optical properties, namely transparency, which is what we saw in the earlier slide. So we further extended our studies to include lightly filled formulations. And the reason why we used formulations that contain talc is essentially for two reasons. One is to further enhance stiffness, and also lower CLT, or coefficient of linear thermal expansion. So both of that are possible when you add talc in, because talc will give you higher stiffness. And since talc does not show any expansion in the temperature range that we test, more talc you have, we get lower CLTE. So like in the previous case, we also compared the performance of our commercial G1730 and 3 new ACBS grades called ACBS 3, 4, and 5 with the POE, which is Engage 8200. Again, the horizontal line is the reference line that corresponds to the POE performance. And we would like to be ideally higher than 100% for all properties except for CLT. So for CLT, lower the better. So if you look again on the illustration on the left-hand side, we did the same experiment with the injection molded plaque and shining a light from the back. And you can see that the lettering is somewhat diffuse with the POE containing plaque, while it is much clearer in the sample that contains G1730. The other thing that we notice is with the ACBS formulations, we see much higher notched ISOT both at room temperature and low temperature. So what that tells us is we have some room to optimize in terms of both modifier content. In this particular case, we increased the modifier content to about 28% from 25% in the unfilled. And we also have opportunity to further modify the talc level, or what we would call as optimizing the compound with a certain selection of building blocks. So we would be happy to work with you to recommend formulations and do this optimization to satisfy your requirements. So let us now change gears and talk about reducing carbon footprint by incorporating recycled plastics in automotive application. So for when we start incorporating in order to incorporate recycled plastics, we have developed we have our Circular Plus modifiers that are ideally suited for this application. So these Circular Plus modifiers can be combined with PCR recycled streams. They can be mixed plastics or waste streams to enhance performance. So we have 2 family of products, one called the compatibilization series and the other called the performance enhancement series. These products can be used with polyolefins and polyamides, 2 of the common plastics that are used in automotive application. With the performance, and they also work broadly with other, and also with both natural fibers. With the compatibilization series, when the recycled stream has a engineering thermoplastic such as a polyamide, the compatibilization series is a better option because there is a reactive compatibilization that enables a higher level of performance. Most tier 1s and OEMs and compounders would like to incorporate a high level of a recycled polypropylene, what we call as a PCR-PP. One of the challenges of incorporating a high level of a PCR stream is essentially to maintain the performance relative to the virgin polymer or the virgin polypropylene. So we did a small experiment here that shows how we can further enhance the performance of a PCR-PP stream. So in this slide, we compounded our circular plus grades at different modifier levels to a PCR-PP. And we measured various properties, both notably notched izod and stiffness. So as you can see here, with about 3% addition of C2000, we are able to increase the notched izod at room temperature by 1.3, by a factor of 1.3. And it further goes up to a factor of 1.5 when we add 6% of C2000. We see similar enhancement with our C3000 grade as well. So as you all know that when you enhance impact, there is also a slight trade-off in modulus, and which is shown here in this graph. But when you compare the performance of our circular plus products to the POE, we have a much better impact stiffness balance. So we don't lose modulus to a large extent as compared to the POE modifiers, as you can see from this slide. So now that we have our circular plus product in the recycle part, we want to find out what happens at the end of the part life. Is it possible for us to recycle that part and incorporate that back into the process stream? So in order for us to determine that, we did what we call as a multi-pass recycling experiment. So in this particular slide, I showed two examples. The first one is our standard PCR-PP, and the second one is a PCR-PP that contains 6% of our circular plus C2000 grade. So at the end of each cycle, we injection molded test specimens and measured performance, izod, stiffness, and flow. And as you can see here, with 5 cycles, we don't see any of the properties being diminished. We are able to maintain both impact and stiffness up to 5 cycles, as you can see in this graph. So what this tells us is we would be able to incorporate these streams back into the process, and this is a wonderful way of incorporating waste streams, minimizing waste streams by introducing them back into the process. So this is basically an example of how a truly circular solution should look like. So what we want to show here is a case study in which an OEM would like to recycle a plastic part back into the process. So we actually illustrate how this can be done with our C2000 circular plus modifier. So in this particular example, we added about 10% of C2000 to ground RPP. We dry blended this, we didn't compound, and directly injection molded into test specimens. So what we notice here is we measured both notched izod at room temperature and low temperature. So with the addition of about 10% of the C2000, we are able to increase the notched izod by almost 200% at room temperature. But more importantly, and what is more impressive is at minus 35 degrees C, that is the cold temperature impact, we are able to enhance that by a factor of 3. So the circular plus modifiers are very effective in enhancing the performance of RPP, as you can see from this slide. So another way to reduce carbon footprint, besides using recycled plastics, is to use natural fibers. Typically, for TPO compounds, talc and glass fibers are conventionally used. As you know, talc goes through a mining process, which is energy intensive and contributes to a higher carbon footprint. So if you can replace talc and glass with a natural fiber such as hemp, we are able to significantly reduce the carbon footprint because hemp is sustainable. Hemp is also is a lower cost option, and it also has a lower density. So in other words, when you make a part using hemp, you're able to lightweight relative to a part containing talc. So what we show in this example is how do the circular plus modifiers work in systems containing a blend of polypropylene and hemp. So if you look at the chart on the left-hand side, when you add 20% hemp to recycled polypropylene, the notched ISR drops off at the onset by almost 40%. So in comparison, when you add 20% talc, we are almost able to maintain the notched ISR. So in order to improve the notched ISR, we add our C2000 and C1000 grades at a ratio of 5% and 1%. And you can see that the notched ISR goes up by a factor of 1.8. If you want a further increase, and it matches up with the performance of the PP talc compound. Now, if you further increase the modifier content to 7% and 3%, we see that the notched ISR goes up by a factor of 2.2. In all of these cases, we are also able to maintain the processability. If you look at the chart on the right, you can see that there is not a whole lot of change in MFR. So this is a wonderful example where we show that we can incorporate a natural fiber such as hemp, and using our circular plus modifiers, we can deliver a combination of both impact flow, impact flex, and processability. So here is another example of a value in use application, which shows how we can design products using our circular plus modifier. So in this particular case, an OEM is interested in doing two things. They want to lower carbon footprint, and they also want to lightweight at the same time. So what we are showing here is a solution that contains 10% of our circular plus modifiers using a natural fiber such as hemp with recycled polypropylene. So using our circular plus modifier, we are able to maintain the balance of impact and flow and stiffness, as you saw in the previous slide. And we had and achieve properties that are comparable to polypropylene talc formulation. So we have replaced talc with 20% natural fiber. So we see that big reduction in lower carbon footprint with the hemp replacing talc. And at the same time, because as I had mentioned previously, since hemp is a much lighter material, we are also able to lightweight the product and get a 14% weight reduction. So I will now hand over to Brian, who's going to talk about using our Circular Plus solution in another polymer matrix. Thank you.
Well, thank you, Raja. So beyond the polypropylene blends with natural fiber, Circular Plus can add value in modifying hemp-filled PA6 as well. So this absolutely works with polyamides. So hemp actually has a bigger effect on PA6, where 20% loading of hemp actually reduces the impact performance of neat PA6 by 70%. So it's a lot. That's without any modifiers added. But what we did is we evaluated both of our compatibilizer performance enhancement series Circular Plus additives that Raja mentioned earlier into an 80-20 hemp-filled compound. And depending on the loading, we saw impact performance improvements of 25 all the way up to 100%. But if you take a look at the flex modulus, the addition of Circular Plus shows up to 20% higher flex modulus, so stiffness, due to improved interaction between polyamide and hemp fibers aided by the Circular Plus modifiers. So with the C1000, we get the synergistic improvement in impact and stiffness at both the 3% and 5% level. So normally when impact increases, stiffness decreases, but we only need a small amount of the compatibilization series to achieve higher impact and also improve stiffness. Now on the right-hand side, you see the effect of a hybrid system, where a small amount of loading of our compatibilizer series combined with performance enhancement series can be used to further optimize impact stiffness balance. So the hybrid system is really just another way or another tool to help you meet your performance specification goals. So to give an example, we had a customer looking to replace talc filled in talc filled PA6 to achieve weight savings and to meet carbon footprint goals. And so the solution was natural hemp fiber. And to make up for the loss of impact and stiffness, we recommended 5% or even less of the C1000 and C1010. And the final product only used 3% C1000. But the surprising effect was that we saw a 50% improvement in impact strength, 10% weight reduction, and obviously a lower carbon footprint. So the additional benefit from lightweighting design you may be aware of is the improved fuel economy that we see on the road. Or in the case of electric vehicles, it can actually help extend the range of the vehicle. Now, we often get asked what other ways we can improve carbon footprint. And so a few years ago, we expanded our Circular Plus product line with Renew Series that offers up to 100% ISCC Plus certified renewable feedstock based on a mass balance concept. And so this is just a drop-in alternative for any of our traditional styrene copolymers, or SBCs, to incorporate certified renewable content and significantly lower carbon footprint. So we currently have plants certified in Europe and North America, with Asia coming online soon. So as an example, just dropping in Renew, equivalent of our traditional polymer, netted the customer a 0.8 kg of CO2 equivalent per kg reduction in carbon footprint per part. And so the finished part had about 30% renewable content, plus the part was 25% lighter. But I think the best benefit is having replaced a PVC or TPU with TPES means that the part is now fully recyclable. So just to recap, I know we've touched on quite a few ways that Kraton can help you enhance your circular design across EV part redesign, lowering carbon footprint, and achieving end-of-life recyclability. As you can see here on the slide, there's plenty more opportunities we not have time to cover today, but feel free to reach out if you have any interest in any of these topics, and we can certainly discuss offline. But before we address your questions at the Q&A, we have one final poll question for you. You can see on your screen here. So we'd love to hear which topics that we covered today were most relevant to you and your customers. So if you could take a second and please select the options below, and we'll reveal that here in a second. Okay. So the top two that we've seen so far are enhanced performance of recycled plastics is the winner with more than half of the votes, and the other second place was reduced carbon footprint. And so very relevant topics that we discussed today. But I think at this point, we appreciate your feedback, and we will hand it over to Christoph to open up the Q&A.
Thank you, Roger and Brian, for both of your contributions. I think it was an interesting talk. In the meantime, we also have quite a lot of questions that came from the audience. So thanks for submitting those questions in the Q&A session. So we'll address this here. Depending on the topic, it will be either Brian or Raja addressing those questions. So let's just start. We have one question here is asking why a combination of C2000 and C1000s should be used to improve the notched impact of natural filler-filled recycled polypropylene. Can this be done using only one of the C products, assuming this means either one of the C2000 or the C1000 products, or does it need to be a combination of both? I think a question to you, Raja. It's more a technical question, I guess.
Yeah, thank you, Christoph, and thank you for the question. So the reason why we use a combination of C2000 and C1000 is basically to couple the hemp to the matrix. C1000 has the functionality that can act as the bridge to couple the hemp to the polypropylene matrix. So if you just use C2000 by itself, we would not see that level of improvement in impact performance as opposed to using a combination of C2000 and C1000.
Okay, thanks, Raja. I think that addresses the question. Next question is, what do you see? And I think, Raja, again, a question to you. What do you see as the upper process temperature limit for the use of these hemp fiber-filled compounds?
So we can run, I think it's about 260 degrees C. In fact, the examples in which Brian showed, we were looking at PA6 compounds. Those are typically run at around 260 degrees C. So I would suspect that that would be closer to the upper process limit.
Okay. And then I think a question more related to Brian. How can we go about receiving samples of any of these polymers or products that were shown?
Sure. So, we typically partner with all our major compounders and different suppliers out there. So we're working with them, but certainly we can provide samples. What we typically would like to do is we first work with you to have an understanding of the requirements. And then once we understand those requirements, then we'll work with you to choose the best grade to provide, and then we'll go ahead and build the samples. So, yep, that is no problem at all. Most of the parts we talked about today, the solutions, are commercially available. So we're happy to work with you on that.
Okay, thanks, Brian. Next question, probably to Raja again. To what extent can haze be reduced even further by adding a clarifier in combination with the SEBS in a homopolymer matrix?
Oh, thank you, Christoph. That's an excellent question. We have not done that experiment. I suspect it can be reduced further by controlling the crystal structure. That is something that we've not looked at. So I don't have a ready answer to it.
Okay. And we can contact this person directly as well to follow up and see what other questions he or she might have. Next question, probably to Brian, I guess. You've shown the mass balance approach, and the question is here basically, what is the source of the renewable content that you show here?
Yeah, so I think it's very common that we all want to stay away from any type of food sources that would be used as a feedstock. So we're definitely not doing that. The feedstock we're using here is a biocircular feedstock. It typically comes from used cooking oil or tall oil. So again, this is not a conflict with any animal or human food sources.
Okay. Next question, probably to Raja again, technical. Have you also done studies on PCR, HDPE for improving impact performance?
Yes, our C3000 series is a good example of using with HDPE. So we do have data that we have not shared here, but we would be happy to share that as well.
Okay, thank you. And probably, Raja, you can stay online. Next question is regarding the translucent TPO data. Did you also do testing to investigate the ductile brittle transition point?
Yes, we have done that. So we do what is called a multi-axial impact test at minus 30 degrees C. We follow the ASTM D3673, which is impacting at a speed of 2.2 meters per second. To give an example, using our G1730 SEBS, we get all ductile failure mode. So we tested 5 samples at minus 30. All of them are ductile failure. We don't see that same trend with the POE examples.
Okay. And next question to that. So lengthy. We often experience scrap in our process, and we typically regrind and include that in other batches. What happens to scrap recycled PP that already has Circular Plus included in it? Will we see a reduction in those mechanical properties? Brian or Raja, I'm not sure who wants to take this one. It's Brian, you want to take a first step?
Yeah, I can take that. Yeah, I can take that. That's a good question. So we've Raja showed a slide earlier about that, showing the multi-cycles that we've studied. So as we looked at multiple cycles, the Circular Plus is the modification performance is really maintained over a minimum of 5 cycles. So as we're incorporating that content back into your process, that performance that we've seen improve with the added Circular Plus, that's going to stay around for at least 5 cycles. So certainly at that point, we'd expect the regrind to be able to be used into your new parts that you're making and without any compromise. And so I think that's a really important point. So thanks for asking that question.
And next question, Brian, I guess maybe for you or Raja, please chime in as well if you see fit. How are Kraton SBCs used in translucent TPO? Are they an additive or a master batch? How are they included, basically?
Yeah, so typically the products that we're selling are additives. And so, we work again with all the major compounders. And so we would say that these products are sold as an additive, as a standalone. They're not being sold as a master batch today. But we would suggest if you wanted to work with your preferred compounder, they can certainly create a master batch for your application. But yeah, the way we sell them today, they are currently standalone additives.
And following question, probably a question for Raja. Why did you choose Engage 8200 as your benchmark in your study?
Thank you, Christoph. Engage 8200 is a very popular grade. A lot of TPO compounders use that as the impact modifier. It is an ethylene octane copolymer 870 density, so I think given the fact that it is commonly used, we used it in our experiments.
And while scrolling to the questions, I see a question that is related to the earlier question, Raja. So this person is asking, did you compare your impact properties of your SCBS solution, G1657 or others, versus new POE with lower TG compared to Engage 8200? A little bit related.
Thank you, Christoph. Yes, we did. Dow has a new product line called Engage 11000 series. And we have not shown the data here, but we did compare. We did make a formulation using one of the Engage 11000 series grade, which has a much lower TG, and it's of the same melt flow as the 8200. We see the same trend. We see much better optics with the SCBS modifiers, both the new modifiers as well as our commercial G1730.
Okay, thanks, Raja, for addressing that question. This moment of time, I don't see any additional questions. So hence, we don't have additional questions, but thank you, Raja. Thank you, Brian, for addressing those questions, for the great presentations. I hope the audience here appreciated the talk and also, of course, the questions. Now, I will say if there's any further questions, any other inquiries that you might have, of course, you can always contact either Brian, Raja, for any further questions, being it technical, commercial. The contact information is showing at this slides. So with that, I would like to thank all of you for your time listening to our webinar today regarding automotive and sustainability. This concludes this webinar. Again, thank you for joining. We're happy to engage with you and see how we can support your innovation journey. Have a great day, everybody, and thanks again. Bye for now.